Hey everyone, welcome to Homeschool. I hope everybody are doing fine. And I am back with a video which will help you to score 60 out of 80 for the 2021 SSLC board examination, that is Karnataka board examination. See, already I covered chemistry part, which is having a weightage of around 25 marks. Chemistry part included 4 chapters. All important aspects and expected questions from chemistry is already over. If you want to watch that video, the link is provided in the description. And this is a second part of that scoring or passing package. And this video is about the physics part. Okay, physics part is really very important because compared to chemistry and biology, physics part is having a weightage of around 28 marks out of 80. So these 28 marks you can score if you can study the chapters electricity, magnetic effect of electric current, light, and sources of energy. And firstly, let me tell you what is there for the year 2021 exam and what is deleted. Electricity, complete chapter is there, don't neglect. Magnetic effect of electric current, complete chapter is there. And coming to the light chapter, reflection part is deleted, whereas refraction part completely it is there. That means half a chapter is deleted, remaining half the chapter is there for the exam. And coming to the sources of energy, non-conventional sources of energy, that is alternative sources of energy, is completely deleted, right? So these are the deleted portions, and let us quickly discuss what are the most expected and important questions from the chapter electricity. See, electricity is really a very important chapter. So you have to concentrate a lot. Fine. Coming to the diagrams, important diagrams from the chapter. Say they will ask you to draw the circuit diagrams here. The first important circuit diagram is a schematic diagram of an electric circuit comprising cell, electric bulb, ammeter and plug key. See, diagrams I am not showing it on the board. I'll tell you the page number and figure so you can refer the textbook and practice them. Or one video I'll make only on all the diagrams so that I'll tell you how to draw the diagrams easily, especially the diagrams from biology part. Clear? And now I am going to mention you the page number and figure number. Note it down and practice. Fine. So this diagram you will observe in page number 94 and figure 12.1. Okay. So very simple diagram. You have to show a circuit diagram containing electric bulb, ammeter and plug key. That's it. And the second important diagram, and this has been asked in your model paper also, that is electric circuit for studying Ohm's law. So this diagram you will observe in page number 98, figure number 12.2. So this is also a very important diagram for this year. And the third one, we all know resistors in series. You have to show a circuit diagram relating to resistors in series, which you will observe in page number 104 and figure number 12.6. And similarly, the fourth circuit diagram which is important is resistors in parallel, and this is also observed in page number 104, figure number 12.7. Okay, so these are the 4 circuit diagrams that can be asked for the year 2021 SSLC board examination. Clear? That's all from electricity chapter, circuit diagram part. And now let us go for the small definitions and units which can be asked for 1 mark as well as in the form of MCQs. So the first important simple definition is what is electric current and what is its unit? So what is the definition of electric current here? Rate of flow of electric charges is called electric current, isn't it? So I is equal to, we will write Q by T. And what is the unit of electric current? It is ampere, isn't it? Okay. And now I am going to tell you one more question here. They may ask you to define ampere, 1 ampere. So how do you define 1 ampere here? 1 ampere is nothing but the flow of 1 coulomb of charge in 1 second, right? Flow of 1 coulomb of charge in 1 second is called 1 ampere, right? So its definition is also important. So this is about our first and simple question. And coming to the second question, name a device that helps to maintain a potential difference across a conductor. What is SI unit of potential difference? So which is the device that is used to maintain the potential difference? That is nothing but battery, isn't it? So this is the device that helps to maintain the potential difference across the conductor. And what is the SI unit of potential difference? SI unit of potential difference is volt, isn't it? And here one more definition I would like to mention here. That is the definition of 1 volt. So what is 1 volt? See, we all know potential difference is equal to work done divided by charge, that is Q. Right? So what can be a definition for 1 volt? It is when 1 joule of work is done to carry 1 coulomb of charge from one point to another point. I repeat once again, 1 joule of work that is done to carry how much of charge? 1 coulomb of charge from one point to another point is defined as 1 volt. Okay, so that is about our second question. And coming to the third question, very simple yet very important, and it's been asked in the model paper also. That is, what is Ohm's law? Write its mathematical form. So how do you define Ohm's law here? It's very simple. So potential difference across the ends of a given metallic conductor is directly proportional to current that is passed in a circuit, isn't it? Directly proportional to current that is flowing in a circuit, provided temperature being constant, right? So this is the definition of Ohm's law. And coming to the mathematical form, so V is equal to IR, we will write, right? So what is V? V is nothing but potential difference, I is a current, and R is a resistance, right? So this is all about Ohm's law and its mathematical equation. Fine. And let us go for the next question. See, the question is, define resistance and resistivity. What are the factors that affect resistance and resistivity? So here I have written the definitions for you, simple definitions. Resistance is nothing but obstruction to the flow of current. Restriction to the flow of current is called as resistance. And can you tell me what is the unit of resistance here? Unit is ohms, right? So remember the unit also. And coming to the resistivity. Resistivity is a property of a material which is defined as the resistance of a material in a particular dimensions, is called resistivity. And the resistivity unit also you have to remember, that is ohmmeter. Okay, say asking a definition of resistivity is very rare, but the resistance you have to remember. And what are the factors that can affect resistance? One is length of a conductor, right? Area of a cross section, nature of material. This is a very important question. Mention the 3 points, okay, which can affect the resistance. And what is the formula? R is equal to, R is directly proportional to length of a conductor, inversely proportional to area of a conductor, area of a cross section of a conductor. So if you have to remove this proportionality sign, we can introduce a constant called resistivity. So R is equal to resistivity into L by A. This is the formula for resistance. And what is the formula for resistivity? Resistivity is equal to R into A divided by L, isn't it? So here L is length of a conductor, A is area of cross section of a conductor, and R is resistance. So these are the two formulas you have to remember, because numericals can be asked based on these formulas. Clear? And I'll be solving few numericals also here. So that's all about this question. And coming to the next question, it is advantageous to connect electric devices in parallel instead of connecting them in series. Why? It's a very famous question. We have to connect the electrical devices always in a parallel but not in series. Why they are asking? Say, I have written a simple answer for you in a simple way. You can check it out. In series, if one component fails, the circuit is broken and none of the components will work. Say, if you connect the components in series, what would happen? If the current, the same amount of current flows through all the devices, if one device fails to work, then the current may not pass through the other devices that are connected in series, isn't it? That's what the meaning. If one component fails, the circuit is broken and none of the components will work, isn't it? That is the major problem if you connect in series. Fine. But in parallel circuit, current divides through the electrical gadgets, isn't it? So here the current that flows is not same through all the devices. It is different in different devices. So what will happen here? This is helpful when each gadget has different resistance and require different current to operate, right? Even if one device fails, the other devices will not get disturbed because the current is dividing here, right? So parallel connection is best if the devices have different resistance and they need different current to work. Clear? So that is the advantage of connecting all the gadgets in parallel, not in series. Fine. So you can copy down this answer so that you will get complete marks in your examination. Fine. And coming to the next question, a very simple question yet very famous. What is Joule's law of heating? Write its mathematical form. So how do you define a Joule's law? I have defined it in a very simple way. You can check it out. The heat produced in a conductor is directly proportional to square of current and resistance and also time for which the current is passed. That's it. So whatever the formula you have, based on that you can define any statement. That's what I have done here, right? Heat produced is directly proportional to square of current, resistance of a conductor, and time for which current is passed. That's it. So that is your definition. And write its mathematical equation they asked you. So H is equal to I squared RT, whereas I is current, R is resistance, and T is time. Okay, so these are few theoretical questions that can be asked from the chapter electricity, and from the chapter compulsorily for 3 marks or 4 marks numericals can be asked. So let us work it out, all models of numericals that can come from the chapter electricity. Say the same question may not come for the exam, but the same model definitely will come in your exam. So I am discussing all models of numericals from the chapter electricity. Let us go for the problem. The first simple numerical. A current of 0.5 amperes is drawn by a filament of an electric bulb for 10 minutes. Find the amount of electric charge that flows through the circuit, right? So what is given? First, you have to write the given information. So for the given information, you may get 1 mark when it is asked for 2 marks, okay, half a mark at least. So what is given? Current is given, that is 0.5 amperes, and time is given, that is 10 minutes, isn't it? And what are they asking? They are asking Q, that is charge they are asking. Fine. Okay, convert the time in seconds here. So how do you convert? 10 into 60, if you do, you will get 600 seconds, isn't it? So this is time in seconds. What is the formula you have? I is equal to Q by T. So if you want to calculate Q, Q is equal to I into T. So what is I? 0.5 amperes into time is 600 seconds. So 0.5 into 600, what do you get? So Q is equal to 300 coulombs. So this is your answer. So it can be asked as MCQ or it can be asked for 1 or 2 mark. Clear? So this is one of the important model, very simple model on electricity. Coming to the next question, again a very simple model. How much work is done in moving a charge of 2 coulomb across 2 points having a potential difference of 12 volts? So what is a given information here? Given information is, charge is given, that is charge is equal to 2 coulombs and potential difference is equal to 12 volts, right? So what are they asking you? They are asking work done. So we have a formula, potential difference is equal to work done by charge. So work done is equal to potential difference into charge. Potential difference given here is 12 volts into charge given here is 2 volts. So work done is equal to 24 joules. So this question was asked as MCQ in one of the model paper. So concentrate a simple question on potential difference, work done and charge. Okay. So this is one model, this is another model. And coming to the third model of a question, which is on resistivity and resistance. Very, very important model. If this question is asked, it can be asked for 3 marks. Okay. The resistivity of manganese wire of length 1 meter is 1.84 into 10 power minus 6 ohm meter at 20 degree centigrade. If the diameter of wire is 3 into 10 power minus 4 meter, what will be the resistance of a wire at that temperature? Okay, first let us list it out what is given. They have given resistivity, isn't it? So what is resistivity here? 1.84 into 10 power minus 6 ohm meter. And they have also given length of a wire, that is 1 meter, and they have given diameter, that is 3 into 10 power minus 4 meter. Okay, so what is the formula you will use here? Okay, before that, what they have asked you to calculate? They have asked you to calculate resistance, isn't it? So our formula is resistance is equal to resistivity into L divided by A. So you want area of cross section but they have given diameter, right? So here area of cross section is equal to pi d square divided by 4, isn't it? So you can put that here in the place of A. R is equal to resistivity L. So instead of A, you can write pi d square by 4. Right? So denominator to denominator goes to numerator. So the formula can be R is equal to resistivity into 4L divided by pi d square. Right? So now you will have to substitute everything. R is equal to resistivity is how much? 1.84 into 10 power minus 6, right? Into 4. So into L. L is how much? 1 meter. So divided by pi value is how much? 22 by 7 into d square. So what is diameter? 3 into 10 power minus 4 whole square you have to do. So we have substituted everything in a place and do the calculation and post the answer in a comments. Let me check out who will post first. So this is another important model in the chapter electricity. So they'll give you one circuit diagram. They will ask you to calculate the total resistance, or they would ask you to calculate the total current. See, this is the circuit diagram and they ask you to calculate the total resistance in the circuit and the total current flowing in the circuit. So you have to observe the circuit diagram very carefully. See, these are the resistances connected in parallel, and this is the resistance connected in series with these things. Right? See, they ask you to calculate the total resistance, isn't it? So you have to do the sum of all these resistances, but you see these are connected in parallel. First you finish off the total resistance of this, and later this and this is connected in series, no? So apply the total resistance formula for series. Okay, so let me calculate the resistance of this since they are connected in parallel. So what is the formula if the resistances are connected in parallel? That is 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3, isn't it? So what is 1 by R1? This is R1, this is R2 and this is R3. So it is 1 by 2 plus 1 by 4 plus 1 by 4. So your Rp you will get as 1 ohm, isn't it? So if you can calculate, the Rp is 1 ohm. And now the total resistance of this, the whole area, this is actually 1 ohm. And this 1 ohm and this 5 ohm is in series, isn't it? So now you apply series formula, that is Rs is equal to R1 plus R2. Isn't it? So what is R1? Let me consider this as R1, this as R2. So R1 is 1 ohm, just now we calculated here, and R2 is 5 ohm, isn't it? So Rs, that is, this is your total resistance. So this is your RT, total resistance, that is equal to 6 ohms. So our total resistance is 6 ohms. Fine. So half the question is over. Now they are asking total current. So what is a total current? Apply Ohm's law. So what is our Ohm's law? V is equal to IR. So I is equal to, it is V by R, isn't it? So total current I is equal to potential difference, how much they give? 6 volts divided by, and what is the total resistance? That is 6 ohms, right? And so you will get I is equal to 1 ampere, right? So this is half a question and this is remaining half of the question. So this is how, based on the circuit diagram, they can ask you to calculate the total resistance or the total current. Clear? So you should carefully observe the circuit diagram. Say this whole thing is connected in series. So that is your total resistance. But initially you have to calculate how much is the total resistance in this particular part. That is, they are connected in parallel, isn't it? So the parallel formula we have used, calculated Rp, that is this whole resistance, and later this and this in series, no? So Rs is equal to R1 plus R2, calculated total resistance. Then we substituted in Ohm's law formula and calculated the total current. So this is a very famous model from the chapter electricity. Let's go for one more problem. Coming to the next model, an electric refrigerator rated 400 watt is used for 8 hours a day. An electric iron box rated 750 watt is used for 2 hours a day. Calculate the cost of using these appliances for 30 days if the cost of 1 kilowatt hour is rupees 3. So how do you calculate? So first you calculate energy consumed by refrigerator. There are two appliances here. One is refrigerator, its power is given, and another one is electric iron, its power is given. Yes or no? So let us do it. Energy consumed by refrigerator. How do you calculate? Energy is equal to power into time, isn't it? So E is equal to power into time, right? So what is power here? 400 watt into time is how much? 8 hours, right? 8 hours. And how many days? In how many days? 30 days, right? So in 30 days, in the sense 8 into 30. So you would be getting around 95,000 watt hours. So that means 95 kilowatt hours, right? So this is the energy consumption by refrigerator in 30 days. So similarly, calculate energy consumed by iron pan. Yes or no? Is it iron pan? Oh, okay, iron box in 30 days. In 30 days. So how do you calculate? E is equal to power into time. What is the power they have given here? 750 watt into what is the time? 2 hours a day. So 2 into in how many days? 30 days, isn't it? So 30. So you would be getting around 45,000 watt hour, right? So that means your energy is equal to 45,000, in the sense kilowatt hour I can write, isn't it? So total energy is how much? So total energy consumption in 30 days is 95 plus 45, 141 kilowatt hour, right? Fine. And now you see they are asking the cost out of it, and they said 1 kilowatt hour costs around how many rupees? 3 rupees, right? So 141 kilowatt hour of energy costs how much? So it is 141 into 3, that is around 423 rupees, right? So this is your final answer. So this is again a very, very important model from the chapter electricity. So all different models I have shown from a chapter. So that's all about the numericals from the chapter. I don't tell you the same question can be asked, but the same model is definitely asked in the 2021 board examination. Clear? And one more last question we will see, simple one. What is the use of ammeter and voltmeter? So what is the use of ammeter? So ammeter helps us to measure the current, helps to measure the current, that is I, isn't it? So voltmeter helps us to measure voltage, isn't it? And ammeter must always be connected in series, and voltmeter is always connected in parallel to the device. It is always connected to the parallel to the device. Clear? So this is again a simple question from electricity. So these are the important and most expected questions from this chapter. Now let us move on to magnetic effect of electric current, which is again a really very important chapter for 2021 SSLC exam. The magnetic field of electric current is completely a theoretical concept. So you have to write, there are few definitions. From these definitions, at least one question can compulsorily expected for 2021 exam. And you can see the first question, very important. What is magnetic field? Mention the properties of magnetic field lines. So here I have written the answer in a simple words so that you can write in your exam. You can take a screenshot of a board, or you can pause the video and write down in your books. So this will help you a lot. And magnetic field definition. It is a region surrounding a magnet in which force of magnet is detected, right? So around a magnet, there is a particular area, only there magnetic force is experienced. Out of that, there is no magnetic force. So such a region is called as magnetic field. And properties of magnetic field lines. Magnetic field lines are closed curves, right? Say this diagram is also very, very important for you. This is South Pole and North Pole. And how do you show magnetic field lines? They emerge from North Pole and merge in South Pole, isn't it? Emerge from North Pole and merge in South Pole. Say this is how you have to show. Arrow mark carefully you have to show, and something like this, right? Arrow mark you show like this. So this diagram is very, very important. So the first property is magnetic field lines are closed curves. They are always circular loops, and they emerge from North Pole and merge in South Pole. The third property, magnetic field lines never intersect with each other. Next, magnetic field strength is maximum at the pole, right? So these are the four properties you have to mention. Very, very important question. And coming to the three definitions, I am discussing the three definitions here. From these definition, at least one definition is compulsorily you will observe in the 2021 board paper, right? This is my 100% prediction. So listen to the definitions carefully. I have written on a board also. You can copy down. First one, define right hand thumb rule. So how do you define right hand thumb rule? In a right hand, if thumb indicates the direction of current, then the curled finger indicates the direction of magnetic field, isn't it? So that is the definition of right hand thumb rule. So using right hand thumb rule, we can find out the direction of magnetic field in straight conductor. In straight conductor. This is also a very, very important point. And coming to the second definition, define Fleming's left hand rule and Fleming's right hand rule. First, we will discuss Fleming's left hand rule. Stretch the thumb, forefinger and middle finger of your left hand such that they are perpendicular to each other. Okay, stretch forefinger, thumb finger and middle finger to each other. I mean, they have to be perpendicular to each other. And what does each and every finger indicates? Forefinger points the direction of magnetic field. Okay, so forefinger, that is this finger, indicates the direction of magnetic field, and the middle finger points the direction of current, and the thumb finger indicates the direction of force experienced on the conductor, isn't it? So forefinger, middle finger, thumb finger. So if the forefinger indicates the direction of magnetic field, middle finger indicates the direction of current, then thumb finger will tell you in which direction the force is experienced on the conductor. Okay, so that is the definition of Fleming's left hand rule. Fleming's left hand rule talks about the force experienced by the conductor when a current carrying conductor is kept in magnetic field. Okay, and Fleming's right hand rule will tell you about electromagnetic induction. Clear? Say you can write the same sentence here. You have to stretch the right hand forefinger, middle finger and thumb finger so that they are mutually perpendicular to each other. If forefinger shows the direction of magnetic field, thumb shows the direction of motion of conductor, then middle finger indicates the direction of induced current. Okay, so forefinger you have to take the right hand and stretch forefinger, middle finger and thumb finger perpendicular to each other, and forefinger indicates the direction of magnetic field. Thumb finger will indicate the motion of conductor and middle finger will give you the direction of induced current. Okay, so this is actually for electromagnetic induction. Okay, there is lot of difference between Fleming's left hand rule and Fleming's right hand rule. You can copy down or you can take a screenshot of a board also, right? So very important definitions. And one more definition is there, that is what is electromagnetic induction. Changing magnetic field in a conductor induces electric current in another conductor is called as electromagnetic induction. I'll repeat once again. Changing magnetic field in a conductor induces electric current in another conductor is called electromagnetic induction. Right? So these are the various definitions from the chapter which you have to remember, and definitely one definition can come for the 2 marks. Okay, fine. And now let us go for principle, working and construction of electric motor and principle, construction and working of electric generator. Again, among these 2 questions, one question definitely comes for 3 marks. So you must know how to draw an electric motor, how to draw electric generator, and you must explain the principle, working and construction. I will show it on a board so that you can learn easily and copy in your books. Very much compulsory question, that is explain principle, construction and working of electric motor. Right? Say electric motor is the one which converts electrical energy into mechanical energy, and its principle you can see here. I have nicely drawn the figure, gave principle, construction and working. As it is, if you can write in your examination, you will get complete 3 mark, guys, and this is a compulsory question for 3 marks. Either electric motor or electric generator, they will ask you in this way. This is electric motor, and in the next question I will show you electric generator. Clear? See the principle. A force is acted upon a conductor when current carrying conductor is kept in a magnetic field. Okay, say when a current carrying conductor is kept in a magnetic field, you know this ABCD is a coil which is a current carrying conductor kept in a magnetic field. What happens? This conductor experiences a kind of force that is responsible for the motion of this conductor. So that way electric energy is converted into mechanical energy. Clear? So that is the principle of electric motor. And coming to the construction, say construction means what you have taken here for the figure, you have to explain. Say you took a magnetic field north and south pole, and this is we call armature coil. So this is ABCD is the armature coil, and you see this armature coil is connected to split rings. Say these are called split rings. It's very easy to draw a diagram. Just do it this way. So coil connected to split rings. These are our split rings. Split rings are again connected to brushes. These are called carbon brushes. X and Y are carbon brushes. P and Q are split rings. And X and Y are connected with a battery. Right? This is a wire with battery and plug key. Right? And this one is a axial. In the middle you have a long pipe like structure. No, it is a axial. That means it can rotate. Right? Say that way our electrical energy is converting into mechanical energy. Say this figure you have to explain. That's what we mean by construction. See, I explained it in a short way. The coil ABCD is placed in magnetic field connected to split rings. This coil is connected to split rings P and Q, touch two conducting brushes. So these split rings are touching two conducting brushes, that is X and Y respectively. Right? X and Y are again connected to a battery. That one you can mention. One more point here. Right? So this is all about construction. Now let us learn about working. Okay? Current enters from source battery to X. Current enters from source battery to X. Okay? And then X to split ring P. Okay? And then to ABCD. Current is entering to X. X to P. P to it is moving to ABCD. Right? We find force acting on AB pushes it downwards, while force acting on arm CD pushes it upwards. What do you mean by this? When current was flowing, AB arm goes down, okay, CD arm comes up. So that way force is acted upon ABCD. AB arm is like this. AB is coming down. This is AB, this is CD. AB is coming down, CD is going up. That way armature coil is moving. Okay, so when the coil is moving, automatically the axle that is there here, that will also move. Okay, that's what. Thus the coil and axle rotate in anti-clockwise direction. So coil as well as axle both are rotating in anti-clockwise direction. Okay, that one rotation we will call it as half rotation. Okay, so at half rotation, Q makes contact with X and P with Y. Okay, so once the coil has rotated half the way, what will happen? Say this side is coming here and this side is coming here. That means your Q, the split ring Q is making contact with X. Split ring, the coil is connected to split ring, no? So when the coil, this is moving here, this is coming here, automatically what happens? This split ring gets connected to X and this P split ring gets connected to Y carbon brush. So automatically what is happening? Direction of current is getting changed, right? Now current gets reversed. This way coil and axle rotate half a turn more in a same direction. The reversing of coil is repeated at each half rotation, giving rise to continuous rotation of coil and axle. So this half rotation continuously goes on, and this way because of this the coil and axle continuously rotate. So rotating in the sense what? Mechanical energy. So this way electrical energy is getting converted into mechanical energy. Clear? So this much you have to mention in your answer. Say if you want, you can take a screenshot of it so that we will go for the next question. This is our principle, construction and working of generator. Say what is the principle? It's very simple. Principle is based on electromagnetic induction. That means changing magnetic field in a conductor produces electric current, isn't it? So that is our electromagnetic induction. See, you can see the diagram here. Diagram is somewhat similar to our electric motor only. So two magnets, and ABCD is the armature coil, and one end of the armature coil is connected to one slip ring. These are called as slip rings. Okay, in case of electric motor, we used slit rings. They are slit rings are different, slip rings are different. Slit rings will act as a commutator there. That means they will help to change the direction of current. But here we are using slip rings. Okay, so AB is connected to slip ring 1 and CD side of a coil, CD side of a coil is connected to slip ring R2. Okay, slip ring R1 is connected to the brush B1, slip ring R2 is connected to the brush B2. So B1 and B2 are connected to galvanometer, right? So this is the setup. That's what the construction. Coil ABCD placed between magnetic poles. The two ends of the coil connected to slip ring R1 and R2. AB side is connected to R1 slip ring. CD side is connected to R2 slip ring. Okay, R1 slip ring is connected to the stationary brush B1. R2 slip ring is connected to the stationary brush B2. B1 and B2 is again connected to galvanometer. Galvanometer will help us to check whether current is produced or not. Okay, fine. And now we will see working. Working is very simple. When axle rotate, this is the axle. With the help of this, we are trying to rotate this armature coil. So I rotate the coil so that AB moves up. Say if this is AB, CD. So AB will move up, automatically CD comes down, right? So when axle rotated such that AB moves up and CD comes down, so clockwise rotation, it is rotating in a clockwise direction. Induced current sets up in ABCD direction. So whenever the coil is rotating, actually change in the magnetic field takes place. So that is responsible for inducing a current, that is creating a current. So how is the current direction? Current direction is also clockwise. So when a coil is moving in a clockwise, current direction is also clockwise only. Say current will produce and it will move from AB. Okay, it will move from AB and later it will come down to CD, and CD side is connected to the slip ring R2, no? So R2 is again connected to B2, no? So current will come to B2 and then it is going through galvanometer and again it is going to B1 and then AB, right? AB, CD, B1 galvanometer, B2 galvanometer and B1. Okay, after one rotation, what happens? Your CD will go in the place of AB, AB will come in the place of CD, right? So at half rotation, what is the direction of current? Again, current will go in a clockwise direction. So that means now the current is moving from CD to AB, right? So how does it move? CD, AB and then to a brush B1 and then galvanometer and then B2, right? So at every half rotation, direction of current is changed. Such a current produced is called AC current. So this is actually AC generator. Okay, so initially as I rotate the axle, AB is coming up, CD is going down, clockwise movement. So that way current is produced and the current direction is also through AB. First it is produced here, it will go to AB, BC, CD and CD is connected to B2, no? So B2 and again it comes in a circuit, it goes through galvanometer and again it will go to B1. And after half rotation, CD is coming in the place of AB, AB is coming in the place of CD. So current goes in CD, then BC, right? And then AB is always connected to carbon brush B1, right? So B1 and later galvanometer and then B2, right? So at every half rotation, you see direction of current is getting changed. That's why such a current we are calling it as AC current. So AC current is produced in AC generator. See, whenever you use slip rings, AC current is produced. If you use slit rings, DC current is produced. So what do you mean by DC current? The current whose direction will not be changed, okay, randomly. It flows in only one direction. AC current's direction changes periodically, right? So that is the difference between AC current and DC current. So difference between AC current and DC current also can be asked. AC current's direction changes periodically. DC current direction does not change periodically. Clear? So that is the difference between AC and DC. So this is the principal construction and working of electric generator. And I repeat once again, electric motor and electric generator, among the two, one is compulsorily can be asked for 3 to 4 marks, and this is a compulsory question from this chapter. Okay, and now we will move on to the next type of question. See, the next question, very simple. Differentiate between electric motor and generator. See, just now we have learned electric motor and electric generator. So what are the differences you can give here? Say here, our electrical energy is getting converted into mechanical energy, isn't it? But here, opposite. Our mechanical energy is getting converted into electric energy. So that is one point of difference. And here, motor works on Fleming's left hand rule, right? And electric generator works on Fleming's right hand rule. So this is another point of difference you can mention, right? Very important question. Next question. What is the importance of earth wire and fuse? Say we will do something called earthing with the help of earth wire, isn't it? So what is that earth wire? Earth wire is the one which has least resistance. Least resistance, so that during leakage of any current on a metallic body, what happens? All that current goes through earth wire and current gets disposed in earth. That process we will call it as earthing, right? So that the user is protected from electric shocks. Clear? Say for example, you have an oven. It has a metallic body. Somehow the current is getting leaked. Say if you touch, you will get a shock. But sometimes you will not get a shock all the time, because whenever current is leaked, what happened? All that current would go to a wire called earth wire. So since it has less resistance, the current would like to move through this particular wire, and it moves through the wire and current gets disposed in the earth. So that is the use of earth wire, isn't it? And what is the use of fuse? So fuse is some instrument that is present in a circuit. Actually this instrument protects the circuit. It can protect the circuit from short circuiting and overloading. Short circuiting and overloading. Okay, so that is the importance of fuse. And here one more thing I would like to tell you. You better learn the definitions of short circuiting and overloading, and you must know the difference between short circuiting and overloading also. Clear? Okay. And the next one is, what is the advantage of AC current over DC current? You see, AC current is the one whose direction changes periodically. DC current's direction will not change periodically, right? AC current is better than DC current is because electric power can be transmitted to a longer distances without the loss of much energy, right? So what is the answer you can write here? Electric power can be transmitted to a longer distances without losing much energy. Okay, so this is the advantage of AC current over DC current, right? So, and the last question, What is the use of galvanometer? So galvanometer helps us to detect the presence of current. Helps to detect the presence of current, right? So that's all about the questions on magnetic effect of electric current. I think if you can read these questions, this is more than enough. You can score, maximum marks from the questions that they can ask from this particular chapter. And now let us move on to light chapter, where in the light chapter, reflection is completely deleted. We will discuss the questions on refraction. See guys, the very first question from light chapter is, mention the laws of refraction. Okay, see there are 2 points you have to mention as it is. It can be asked for 2 marks. First point, the incident ray, the refracted ray and the normal all lie in same plane. Very easy point. Next one, the ratio of sine of angle of incidence to the sine of angle of refraction is constant, which is nothing but sine I by sine R is constant. And this particular law, we also call it as Snell's law. And they will ask you what is Snell's law for 1 mark. Then you can mention this point for Snell's law. The ratio of sine of angle of incidence to the sine of angle of refraction is always constant. Clear? Okay. And the next question, what is refractive index? The refractive index of diamond is 2.42. What is the meaning of this statement? Very, very important. So, refractive index definition, the extent of change in the direction that takes place. The extent of change in the direction of light, it should come. Direction of light that takes place in a given pair of media is expressed in terms of refractive index. See, the light travels faster in air, but the light travels very slow in glass or other medium, isn't it? To how much extent the speed of light is changing when it is traveling from one medium to another medium. So that extent of changing the speed of light in 2 different medium is expressed with the help of refractive index, right? Okay. And they are asking you, the refractive index of diamond is 2.42. What is the meaning of this? That means the speed of light in diamond is lesser by a factor 2.42 as compared to the speed of light in air, Okay, say speed of light in air is more, but the speed of light in diamond is very much less as compared to speed of light in air. But how much less? By how much factor? By 2.42. By this much factor, the speed of light in diamond is lesser as compared to the speed of light in air. See, this is the most important type of a question that you can expect this year for 1 mark. Say, try to remember this concept. Okay, I told you by taking as an example of diamond, but they can ask you with other examples also. So the meaning is always this: speed of light in a particular medium is always lesser compared to the speed of light in air, but how much lesser? By this much factor. That is in diamond. It will be different for different medium. Okay, so this is one part of the questions, and the next is very, very important, the ray diagrams. See, you have 6 ray diagrams for convex lens and 2 ray diagrams for concave lens, and from 8 ray diagram, 1 ray diagram is compulsorily be asked for 3 marks. So this is the compulsory question from this particular chapter. Clear? Let us learn how to draw the ray diagrams now. I'll show all the ray diagrams and what you have to write after doing a ray diagram, everything I'll tell you. So first is ray diagrams of convex lens I'll show. There are 6 cases, and case number 1 is if the object is at infinity, right? Let us see how to draw the ray diagram in this case. And this is our convex lens with O as optic center, and this is our principal axis, isn't it? This is principal focus f1 and this is 2f1. So this is our f2, this is 2f2. Okay, you will have 2 principal focus and 2 center of curvatures, right? Okay, so if my object is placed at infinity, okay, so what you have to do, you should take an incident ray which is parallel to the principal axis. Always when a ray which is parallel to the principal axis will move through the principal focus. Okay, so here this is a converging lens, so the refracted ray is moving through f2, and I'll take another incident ray which is parallel to the principal axis. So this ray also would move on to f2. So here is what our image formation takes place. So here they will ask you the position of image. Okay, position is what? At f2. And they'll ask you nature of image. Nature is what? Diminished. Nature is highly diminished, and it is real and inverted image you will get, and it is diminished, or you can say it is point sized. Okay, so this is our case 1, right? And now let us see our case 2. So what is case 2? You are keeping your object behind 2f1, right? So object is behind 2f1. So how do you show the ray diagram in this case? Say this is your optic center. So this is your principal axis, and this is f1, 2f1, right? And this is f2, and this is 2f2, right? And our object is just behind our 2f1. So you will draw one incident ray, that is, see, you have to show the arrow mark properly. Show the arrow marks both in incident ray as well as refracted rays. If you miss the arrow mark, then marks will get cut. Remember this. So I'll take one incident ray parallel to principal axis, then definitely it will cross towards f2. And I am taking another incident ray which is passing through optic center. So whenever an incident ray is passing through optic center, what happens? It will move straight. So where are you getting your image? Image you are getting between, say, let us write the points here. Position of image is exactly between what? f2 and 2f2, right? And the nature of image is what? Real and inverted. Real and inverted, right? Say, and here also it is diminished. You will get diminished image, right? So this is your case 2. Coming to case 3. Case 3, where will you place the object? If I place the object at 2f1, so how do you show the diagram, ray diagram? This is your optic center, principal axis, this is f1 and this is 2f1, and this will be your f2 and this is 2f2. So I am keeping my object exactly here. So what will I do? I'll take an incident ray parallel to principal axis and it will pass through focus f2, and I'll take another ray passing through optic center, are meeting here. So straight away you are getting your image at 2f2, isn't it? So let us write the position here. Position of the image is at 2f2, and what is the nature and size of nature is real and inverted, and size is same size. Okay, you will get same size image which is having same size as that of object. So that is your case 3. And coming to case 4. So in case 4, what will I do now? I'll keep my object between two F1 and F1, right? So now what is the ray diagram that you can draw in this case, and where will you show the position of the image? So this is F1, this is 2F1, F2, and this is 2F2. So I am keeping my object here. I'll take an incident ray parallel to principal axis. It will pass through focus, and next I am taking a ray which is passing through optic center. So this would move out. So where are you getting your image? So definitely you are getting your image behind 2F2. So what is the position of the image here? Position is behind 2F2. So what is the nature of image here? Nature is real and inverted, right? And the size of the image is enlarged. So from here, enlarged images you will observe, right? So this is your case 4. And now case 5 and case 6. Case 5. Say if I keep the object at F1, right at principal focus F1, how do I draw the ray diagram? This is optic center, principal axis F1, and what is this? 2F1, and this is F2, this is 2F2. So I'll keep the object right here. So what do you get? You get I'm taking one incident ray parallel to principal axis, so that would pass out through F2, and I'm drawing another incident ray passing through optic center. So I would get something like this. So here this means these two would meet at infinity. So I can write position of image is at infinity, and nature of image is real and inverted, whereas the size is enlarged, isn't it? So this is what you can write for case 5. And case 6, which is very, very important, and that is exactly if I place my object between F1 and optic center O. So how do I show the ray diagram in this case? Say this is optic center O, and this is our F1, and this is our 2F1, this is F2, and this is 2F2, right? And I am placing my object here. So how do I take? I take one incident ray parallel to principal axis that would move on through F2, and I take another ray passing through optic center, and that would move in this direction. They won't meet anywhere in the opposite direction. So what do? I will project these lines backside and see where are they moving, where are they meeting. Definitely they are meeting here, right? So here they are meeting, and you get virtual and erect images, isn't it? So what is the position? Position of the image is same side as object. Okay, wherever you kept your object, that side only your image is formed. And what is the nature of image? It is virtual and erect images are formed, right? So these are the 6 ray diagrams, so which is a compulsory question from this chapter. Say at least one can be asked for 2 marks. And we will discuss concave lens ray diagrams also. There are only 2 cases, very simple. So these are the 6 and plus 2 from concave lens. So among 8, at least 1 can be asked for 3 marks. They are actually very easy. Only thing is you have to practice. Clear? And you have to perfectly mention these arrow marks of incident rays and refracted rays. Perfectly mention the positions correctly. You have to draw little more neatly than me. Okay, I have shown you all these very roughly. Practice this and have a perfection. So for the concave lens, we have only 2 cases to learn, right? So that is case 1. If we keep our object at infinity, let us see what would happen. So how do you draw concave lens? And this is how. This is optic center and this is principal focus, and this would be f1 and 2 f1, f2 and 2 f2. Okay, see, I am keeping my object somewhere at infinity. So what would happen? I will draw a ray parallel to principal axis. Since it's a diverging lens, what would happen? The rays would diverge. Refracted rays would diverge, right? And I'll draw one more ray parallel to the principal axis, that will also diverge. But image will not form on the other side of the lens. If you project back those refracted rays, you see where are they meeting? They are actually meeting at f1, isn't it? So here is your image getting formed. So what is the position of the image here? Position of the image is at f1. Okay, and what is the nature of image? Nature of image is virtual and erect, right? But the size is diminished, highly diminished, or you can write it as point sized. You will get point sized image, isn't it? Fine. And now let us see another case. In case 2, we can keep our object between infinity and optic center O. So if you keep your object between infinity and optic center O, how do you show the ray diagram? This is f1, this is 2 f1, and this one would be f2 and this one would be 2f2. Okay, let me keep my object here. Okay, so what are the incident rays I can draw? One incident ray is parallel to principal axis, and if right, that would diverge, and another incident ray I will take that it is passing through principal axis and there won't be any change in the direction. See, where are they meeting? Say they are actually meeting here, right? So what is the position? Position is anywhere between infinity and optic center, right? Say anywhere between that you will get, and the nature of image is virtual and erect, and it is diminished. Size is diminished, isn't it? So this is the ray diagrams of your concave lens, right? And now from the same chapter, at least one problem can be asked for 3 marks. Okay, say based on a concave lens and based on a convex lens, one problem is asked where you have to use the lens formula and calculate. And for the problems, one video link I will provide in the description. You can go to the video and watch. Problems are also important from the chapter. Compulsorily one problem they will ask for 3 marks. Okay, and for the problems video link I will share in the description. Do watch that video for further problems on refraction. Clear everybody? Fine. So with this I am completing refraction, that is light chapter, and I will move on to the sources of energy. See the first question in sources of energy, which is the most important question. Definitely one question can be asked either for MCQ or 1 mark from this particular concept, that is about biogas. Okay, what is biogas? Biogas is a boon to farmers. Why? So what is biogas? Biogas is obtained by the decomposition of animal and plant waste with the help of microorganisms in presence of water, right? Say the wastage of animals and plants undergo decomposition in presence of microorganisms. The gas obtained, we call it as biogas. Clear? So, you know what are the advantages of biogas? They can ask you the advantages. I have given you 2 points here if it is asked for 2 marks. First one, it produces clean fuel. Next one, the remains of biogas plant can be used by farmers as manure. So whatever the waste material that is there after the generation of biogas, and that waste is used as a manure in agriculture. That is why we say biogas is a boon to farmer, right? It is a great boon to farmer. It is because it is used by farmers as manure. That has to be your answer. Okay. And one more thing, they may ask you the diagram of biogas plant, the diagram and how the biogas is produced, all that method you must be familiar. It's an easy aspect only. I no need to explain, isn't it? And the diagram you can refer in a textbook. Clear? Fine. And the next important question, what are the features of good fuel? Right? See, I have mentioned here the 4 points. You can observe them. It has to be easily accessible. That means the fuel has to be available easily for the use. And the fuel must able to do large amount of work per unit volume. That means little fuel must able to do large amount of work. Then we can say it's a good fuel, right? Third one, it must be easy to store and transport. And last but very important, it should be economical also. That means it should be cheap to use, right? So these are the 4 points you can mention. And the next question is advantages and disadvantages of hydropower plants. Hydropower plants, advantages and disadvantages. See, hydropower plant, it's like advantages, you know, large amount of electricity continuously can generate, right, from the water resources. I can say it is a renewable source of energy, renewable source, I mean water we are using to generate electricity, so that way it is advantageous. And once you set up, you know, the generation of electricity takes place continuously over the years, so that is another advantage, right? But it also has lot of disadvantages also, where large area is required for the setup of hydropower plants, right? You need to make empty, you know, the forest area and large amount of vegetative area where it's not that much good for the environment, right? And you know, the maintenance is also very much costly. You have lots of disadvantages that way. You can refer my videos on sources of energy where I have listed so many advantages and disadvantages. Similarly, the next question is advantages and disadvantages of thermal power plant. Thermal power plant, right? See, here also thermal power plant, you know, you will generate electricity from coal. That is the main disadvantage, isn't it? From coal. Coal is non-renewable source of energy. Non-renewable source of energy, isn't it? Say, this is the major disadvantages. And coal mines are not available in every area. So wherever coal mines are there, there only you have to set up thermal power plant. That is one disadvantage. But still, though we have lots of disadvantages, we 60% of your electricity gets generated from thermal power plant only, is because the production of electricity is very much high from thermal power plant, and it is easily accessible, right? Maintenance is also very nice. I mean, maintenance is takes less cost. Once you set up, you can continuously use it for many number of years. So all that advantages are also there. So all these points I have detailedly explained in my videos. You can check the playlist of sources of energy, right? And actually the non-conventional sources of energy is deleted, but still one or two questions were asked in the model papers. So you can refer the model papers also. And conventional sources of energy is there for this year. Try to revise all conventional sources of energy. Say if the question is asked from this chapter, it will be asked very much directly. So all that direct questions you can learn. So with this, I am completing the physics part. I think I have given enough justice for you. The weightage of physics chapters is 28 marks. Say easily, whatever I have taught you today, if you can read all of them thoroughly, you can easily score 20 marks out of 28. Minimum 20 marks definitely you can score. So let us hope for the best and meet up with the third part, that is a video on biology chapters, and biology is having a weightage of around 27 marks. Okay, so see you with the next video, and share the video to the maximum people, because this year many of the students have deprived from education. Let everybody get benefit. So share the video without fail, and do subscribe our channel to learn the concepts in a easiest way and in a detailed way. Thank you so much.